Hi, everybody. Yesterday, we focused on standard form systems, and as you can see by the title of these notes, we are going to focus in on y equals mx plus b systems, or in other words, slope-intercept form. And they're much, much different than what we looked at yesterday. We have strategy again, so let's go through our strategy. The first step is to realize you have a rate and an initial value. So while we're reading, the goal will be that with practice, as we're reading, we'll realize that the situation is giving us some rate and an initial value. Step 2 will be to define variables. And when we're looking to define variables, in this situation, we will look for per, each, and every. Any of those keywords that we see, that will tell us what X will represent. Lastly, step 3 will be to set up the two y equals mx plus b equations for what's being compared and solve. So a slope-intercept form system will look like two slope-intercept form equations, y equals mx plus b, y equals mx plus b. Again, the best way to learn how to use these steps is to actually try one. So let's read number 1. You are trying to decide between two jobs to take. The first job at Travelers Insurance pays $10,000 bonus plus $40,000 per year. The second job at Aetna Insurance pays a $20,000 bonus plus $35,000 per year. How many years would you need to work so that it would not matter which job you took? That step of underlining the question, I know we didn't write it, but we should still always do it. So let's underline the question. As we were reading, we get the sense of a value plus something per year. Value plus something per year. So this is helping me to see or realize mentally, I have a rate and I have an initial value, and I'm comparing two things. We're comparing Travelers to Aetna. So how many years would it take to work so that it doesn't matter which job you took? Before we can answer that question, we have to define our variables, x equals, y equals. In our steps to define variables, we're reminded to look for per, each, or every to know what x is. So this is a bonus. That's a flat rate. You only get one bonus a year. But notice, $40,000 per year, $35,000 per year. So x will equal number of years. And then once you know how many years you've been working at a company, you know your total salary. We are going to have one equation for Travelers. And then what's the other job? Where's the second job? The second job is Aetna. So we're looking to set up a y equals mx plus b equation for Travelers and a y equals mx plus b equation for Aetna? Well, for travelers, I know that you make $10,000 bonus and then $40,000 per year. So you can either write that as 40,000x plus that flat $10,000 bonus, or it doesn't matter. I'm trying to say that you could have written 10,000 plus 40,000x. As long as x is next to 40,000, you're good. For Aetna, what do we know about Aetna? Aetna, you make a $20,000 bonus and $35,000 per year. That per year piece is my rate. And then my bonus is flat, plus 20,000. Now that I have my system, we're ready to solve. Remember that when one or both equations is x or y equals, we will use substitution. For this first one, if you still want to use your solve first sub, second sub, that's fine. So solve first sub, second sub. Both equations are solved for y, so it doesn't actually matter which one I pull for the solve step. I'm just going to put the first one just because, why not? So y equals 40,000 x plus 10,000. For first sub, I'll write the equation I did not use yet, which is y equals 35,000. Oops, forgot the x. Y equals 35,000 x plus 20,000. Line down the equal sign. I have something to substitute in for y, because this says y equals. So, where I see y equals. Where I see y, I will be substituting in this. So 40,000 x plus 10,000 equals 35,000 x plus 20,000. And now we're ready to solve for x. So I want to gather all of my x terms to one side. We've talked about this idea of a goal, right? A goal. I need x equals some number. So I want everything with an x to the left and anything that doesn't have an x to the right. So if I look here, this positive 10,000, that's got to go. So we can subtract that over. I now have 40,000 x equals 35,000 x. And then here, 20,000 minus 10,000, that's a positive 10,000. All right, I'm doing good here. On this right side, I only want numbers. So this 35,000x, no bueno, that's got to move. The opposite of a positive 35,000x would be to subtract it. Subtract 35,000x. Subtract 35,000x. Line all the way across. This is gone. 40,000 minus 35,000, that's 5,000. We're super close. Check this out. To solve for x, the very last thing I need to do is what? Divide by 5,000. Let me get rid of the goal. See if I can move it down. So divide by 5,000. Divide by 5,000. X equals 10,000 divided by 5,000 is 2. What are we going to do next? I don't know y. Y equals 40,000 x plus 10,000. It doesn't matter which one you plug into. I just choose to use the one I happen to write over there. So this will be 40,000 times 2 plus 10,000. That's 80,000 plus 10,000 equals 90,000. What does our answer mean? Well, when I look at my variables, what was x? X is number of years, so that means when she working 2 years will make what true? We just found the answer to the question, how many years would you need to work so that it would not matter which job you took? At 2 years, your salary is the same, 90,000. So working 2 years will make your salary at both places the same. And we're done. Now, moving forward, when I have a y equals mx plus b system, I would like us to get used to the idea of seeing that this says y equals y equals. So setting these equal to each other, we're literally setting this equation equal to this one. And if I look, that's exactly what happened right here. We set one equation equal to another. So starting with the next example, we're going to practice when we have a break-even situation, when are two things equal. We're going to jump right to using this step of just setting one equal to the other and solving. Reasoning on what the graph would look like, these are both increasing lines. So let's say here's the equation for Aetna. And here's the equation for travelers. Right here where those two lines intersect is the ordered pair we just found. Before 2 years, one of the jobs is better, well, or worse, right? This is less than that one. And then after, so let's say this was legitimately my graph. So if you were going to work less than 2 years, Aetna, see how Aetna is higher? Aetna would be better. But look what happens after the 2 years. Travelers becomes better. So this matters. When people are looking for jobs, there's a point where it doesn't matter which one you work at. For you, if you were considering these two jobs, at 2 years, you'd make the exact same at both places. But if you were going to work less than 2 years, one is better. If you were going to work more than 2 years, another is better. That reasoning will be the focus of tomorrow's notes. Right now, we're just working on finding when are they the same. But I wanted to kind of introduce us to that next level of thinking that will be coming up tomorrow. Let's look at our next example. Number 2, your family starts a bed and breakfast in your home. You spend $500 fixing up a bedroom to rent. Your cost for food and utilities is $10 per night. Your family charges $60 per night to rent the bedroom. How many nights do you need to rent the rooms to break even? As soon as I see this word break even, I know that it's going to be a y equals mx plus b system. Same thing with this first example. If you look back at the language here, how many years do you need to work so that it would not matter which job you took? That's comparing one to the other. Here, comparing until something breaks even. Break even is a key word for y equals mx plus b. We've underlined our question. Let's define our variables. We're going to look for words like per, each, and every, because as soon as I have a y equals mx plus b, I know I have an IV, dv situation. So for the IV, the independent variable x, look for per, each, and every. Do you see it? Well, I see it. Per night. So I know that x will represent number of nights. Once I know the total number of nights that somebody's there, in general, what's the total cost? Oh, I just said it. The total being discussed is total cost, total money. So we're going to work towards two y equals mx plus b equations. In this situation, I know something about cost, and then I know how much this family is actually going to make. So this example is an example of cost equation and a profit equation. Let's figure out cost. So y equals your cost for food and utilities is $10 per night. Was there anything else about cost? How much did you spend to fix it? You spent $500 to fix this room. So that was a flat rate. You paid $500 to fix it up, and then utilities, right? Heat, hot water, and all that. $10 per night. That's how much it costs you. How much are you making? What's your profit? Well, it tells us that the family is charging $60 per night. 60x. So now I have my equation for cost, and I have my equation for profit. The valid question that any owner of a business like this needs to know is how many nights do you need to rent the room to break even? To figure that out, we will set cost equal to profit. Cost equal to profit. So cost, 10x plus 500, equals profit, 60x. And we can solve. Go ahead and pause here and solve for x. I'm going to subtract 10x from both sides to get x's all on one side. That gets me 500 equals 50x. To finish, I will divide both sides by 50. X equals 500 divided by 50 is 10. Technically, I'm done. Can anybody figure out why? The question was, how many nights do you need to rent the rooms to break even? What does X represent? X represents the number of nights. So you need to rent the room for 10 nights. To break even. Meaning, what does break even mean? That means that your cost is equal to your profit. How much you spent or how much you're spending equals how much you make. If the question asked, what's the monetary value of that, we could plug in to either of these equations. So let's just do that to see what that would look like. I choose the second one. So that's 60 times 10, which is 600. So your break-even money value is $600. And again, we had just written cost equals profit. So that means that if you rent this room out for 10 nights, you make $600. But do you see even a cent of it? Nope, not even a penny. Because that 600 is exactly the cost of that time. So the business would not make any actual money. Yes, technically, they made the $600, but between the cost of the renovations and how many nights so far, they're not actually profitable yet. So business needs to know things like this, because less than 10 nights, not only have they not broken even, they've technically not even made anything yet. So at 10 nights, they break even. Okay. Number 3, Amy is struggling in her algebra class and is looking to hire a tutor to help improve her grades. One tutor charges $40 to join, $10 per hour. Another tutor charges $20 to join and $15 per hour. How many hours will Amy need? Oh, I see a question. Let's underline it. How many hours will Amy need of tutoring for the cost of either tutor to be equal? How much will she be paying? When I was reading, I clearly observed a rate and an initial value, so I know that this is a y equals mx plus b system. It's a good habit to keep writing this in the margin. So let's define variables. X equals y equals. To know what x is, we look for words like per, each, and every. Where do you see per, each, or every? I see it right here. This jumped out to me. Per hour. Per hour. So I know x will be number of hours. And once I know how many hours of tutoring you've had, you know your total cost. So what are we comparing? Like up here, we were comparing cost to profit. In number 1, you were comparing travelers to Etna. Here in number 3, we are comparing one tutor to another tutor. So we'll have an equation for the first tutor, and we'll have another equation for the second tutor. The first tutor charges $40 to join and $10 per hour. So y equals 40 flat rate, plus 10x. My second tutor, what's the charge for this person? Another tutor charges $20 to join and $15 per hour. So that will be 20 plus 15x. Again, $15 per hour, so I know it's 15x. We've got our system. Let's figure out how many hours will Amy need of tutoring for the cost to not matter. It won't matter when they're equal. Cost of either tutor to be equal. So let's see. We are going to set 40 plus 10x equal to 20 plus 15x. Go ahead and pause here, solve for x. I'm going to subtract 40 first. You may have subtracted 15x first. That's fine. We should still get the same answer. I get 10x equals negative 20 plus 15x. I will now subtract 15x from both sides. That gets me negative 5x equals negative 20. To finish this up, I will divide both sides by -5. X equals 4. When I look at how my variables are defined, X is number of hours, so X equals 4 hours. So that's answering the question about how many hours, 4 hours. But notice here we do have that second question. How much will she be paying? To figure that out, we do need to substitute into one of our original equations. I will choose the first one. Maybe you choose the second one. Either way is fine. Go ahead and pause if you choose the second one. We'll compare answers. So this is 40 plus 40 is 80. So as a sentence, the best way to write a sentence is to kind of turn the question into your answer. How many hours will Amy need of tutoring for the cost of either tutor to be equal? So at 4 hours, the cost, I know my cost is $80, is the same there's like 10 different ways to write a sentence here. At 4 hours, the cost is the same. Both tutors would cost $80. However you choose to write it, as long as your real-world answer includes the fact that it's 4 hours when they're equal and that cost would be $80, it's a great answer. We're at the homework section of these notes. This will be for classwork. If you would like to get a jump start, that would be fantastic. Otherwise, really kind of reflect over the notes from today, 1, 2, and 3, and you'll be in good shape for tomorrow's practice. Have a great day.